Hi friends, let's visualize RAG data. Here we have over 1000 points, each representing a chunk in our vector database. We also have the user question and the response generated by the LLM. Okay, and these bigger circles, they represents the chunks retrieved by the retriever, which are similar to our question. Okay, so let's see how to build this visualization for a RAG system in this video. All right, first, thank you very much, Marcus Stoll, for putting a nice blog post, and here is the link to the blog. I'll also provide this in the description. So the code is also by Marcus. All right, so this is not so much a video about the RAG, but visualizing the RAG data. So we don't go much details into the RAG system. I hope by now you are all familiar with the RAG system and how to build. I have a number of videos. Please do check out. All right. So at a very high level, to leverage LLMs with our private data, we build RAG systems, right? So we take all our data, we chunk them into smaller pieces. We create embeddings for each piece. We store them in the vector database. And when we ask a question, we find out similar documents from the vector database. We extract the document content and we provide those content as a context to the LLM so that it can answer private questions based on our private data, right? That's what a RAG system does in a nutshell. Okay, so we need an embedding model. We need a vector database. So here we are initializing a vector database, which is going to use OpenAI embeddings and the model text embedding ADA002. And we are also persisting this vector database locally. All right. And then for this exercise, we are going to work with HTML files. So, and we have those files in a directory. So we are going to use a directory loader. Okay. So we have a folder called docs with a bunch of HTML files and we load the documents. Okay. Let me see. All right. So here I have two documents, two HTML files. One is Elon Musk's and the other one is Steve Jobs, downloaded from Wikipedia. All right. And then we take these two documents. We use this recursive character splitter. We are splitting the documents into chunks of size 1000 with an overlap of 200. That resulted in over 1200 chunks. Okay, so in total we have 1200 chunks. So for each chunk we are going to create a vector embedding and store them in the vector database. All right, now this one is optional. All we are doing is for all these chunks we are generating an ID to store in the vector database so that we can use that ID for metadata purpose. Okay, all right, so here we are adding all the documents or these splits or chunks to our vector database. All right. And then we need to build the RAG chain. Okay. So again, just define the LLM model because this is supposed to be based on the factual answers. We are set this temperature to 0 and we have initialized a retriever based on our vector database and we want the top 20 similar documents. Okay. Now this is a standard template saying, hey, you are an assistant for question answering systems. You will be provided context, answer the question based on the context provided. If you don't know, say you don't know the answer, and also return the sources in your response. All right. And then here we are putting the RAG chain together this runnable, it's similar to a data pipeline which does a sequence of steps, right? Again, if anything is not clear or if you don't know anything, please ask me in the comments below. I'll answer them. But all we are doing is we are taking an LLM, we are taking the prompt, we take the question, and we combine the retriever to generate a response. Okay. All right. So here we have the RAG chain, and we are invoking the RAG chain with a question. In this case, what are the companies Elon Musk is associated with? And it has written an answer. Okay. This is a standard RAG we all know. Now let's see how to visualize this. Okay. So what we are going to do is we are going to build a pandas data frame for convenience, which we can load into our visualization system. Okay. All right. So first we need all the vectors from our vector store, right? So this time we are using our vector store to get all the content, right? All the 1200 plus chunks along with their vector embeddings. Okay. All right. So we got them, and we also wanted the metadata, the document text itself along with the embeddings. Okay. And from that we create a data frame, very simple things like we are getting the ID, the source, the page number, which is not relevant for these HTML documents, but for PDF, we have the source, which is the PDF document name, and we can even have the page numbers like that, right? So the document, this is the actual content of the chunk, and then we have the embeddings. Okay. Now, when we ran our RAG system, as you know, we first run our retriever, which extract 20 relevant documents from the 1200 plus documents, right? Where is it? Yeah. So first we are extracting 20 relevant documents to our question from the 1200 documents we have. Now for this question, let's figure out what those 20 documents are. Okay. So what we are doing here is we are running the retriever separately for the same question. So we get those 20 documents, and using this data frame column document, we are finding out which of these documents are retrieved by the retriever. Okay. So we are just checking which ones from this document column are in the retrieved docs. Okay. If it is there, it's true. Otherwise it's false, right? So it would be like this. For example, this document, it is not extracted, not retrieved by our retriever, right? So all these documents, none of them are in the retrieved documents. All right. So if you sum this contains answer, we should get 20 because our retriever is retrieving 20 documents. All right. So this is the data frame we have. Now let's add two more rows, right? So presently it contains only the vector database data, but we also want to include our question as well as the response so that we can visualize the vector data as well as the question and the answer, how similar and or how near they are to each other. Okay. So we are going to add two more rows like this here. So the first row we are going to add is the question. We call it ID, right? So this is that hash ID we have created, and for the same header, we are adding the question. Okay. So this is our question. What are the companies Elon Musk associated with? Okay. So we have the question, and for this question, we have created the embeddings. Okay. And similarly, we already have the answer or the response from LLM. So this time we set the ID as answer. Okay. So the question is obviously empty. Now this is the answer. And for the answer also, we are creating the embeddings. Okay, so we are adding these two rows to our existing data frame, which contains our vector database data. Okay, so we have built this data frame where we have our documents from the vector database. For the first two records, these are not from the vector database, so it's none. And then we have the embeddings of each chunk. We have the question, we have the answer, and for these two also we have created the embeddings. And here we have marked which documents are retrieved by our retriever. Okay, and this page it is set to -1 for all the documents from the vector database except for our question and answer. Okay, so if you look here, the page will be none for our question and answer record. For the rest, it is -1. When we visualize, you will see how we make use of this page, as well as this contains answer to visualize. Okay, so once we prepare this data frame, another thing we are doing is, now that we know our question embedding, our answer embedding, and each document embedding, we are going to compute the Euclidean distance between our question to answer and to every document within our vector store. Okay, so that's what we are doing here. So to the pandas data frame, every row we are computing the Euclidean or this L2 norm distance to our question embedding. Okay, so we have created one more column in our database called the distance. Okay, now I'll explain one very important point when we visualize. All right, once we created this data frame, we are going to use this library called Renumix. It has this nice visual module called Spotlight. So to the Spotlight, we simply provide our data frame. Now this will open the visual at this port. Now, one of the requirements is this data frame should contain a column called embedding. Okay. Now what it does is, it takes these high dimensional embeddings. I believe the model we have, it creates embeddings of size some 1532 or something, 1500. And then it use this principal component type analysis, the UMAP algorithm. It uses the UMAP algorithm to reduce our high dimensional embeddings to 2-dimensional and then visualize in the 2-dimensional space. Okay, let's see how it is. All right, so this is the URL it provided. So here on the left, it shows the raw data, and by default it also shows this similarity map. Now this UI, it's very it has lots of components. We can configure, you can do a lot of exploration. So the ID, these are all our vector database vector records IDs. Here we have the question, answer. All right, so this is our question. This is the response generated by the LLM. The source of the document. So this will either be Elon Musk Wikipedia page or Steve Jobs Wikipedia page. And then we have the page which is -1 for everything except for our question and answer record. And then here we have the actual document itself, and this contains, it specifies if this document is retrieved by our retriever or not. Since we set top k is equal to 20, so we should have around 20 documents with true and all the remaining documents as false. Now, since I already sorted this by this distance, here you will see all the documents retrieved by the retriever at the top. Okay. All right. So here is the distance. Now, one very important point is here we are visualizing the data in two-dimensional space, but this distance is computed in original embedding space. So 2 points which are very close in that high dimensional space may not appear to be close in this two-dimensional space, because when we reduce from 1500 plus dimensions to just 2 dimensions, we will obviously lose some information, right? So the reason why I'm specifying is, let's do this. All right. Okay. Now let me highlight. So here, if you go to the settings, here you can set the color by, scale by. These two are the important ones. So as I mentioned, we are using this UMAP algorithm, but if you want, you can set it to PCA also. So it will take a couple of seconds to compute the PCA for all our embeddings, right? So by default, this embeddings column should be in the database. Now, here we are looking at this Euclidean distance. So we color code by the distance. Okay. So as I mentioned, let me do one thing. The page, let's set to page. So this is our question. This is our answer. The reason I'm saying that is because if you look at the distance, this is 0.43. Whereas question to question embedding, the answer is 0. So it's not popping up, but this is our question. This is our answer. Now we have colored all these data points by the distance. So as you can see, the blue one, the distance is 0. So the the distance between our question embeddings to question embeddings, which is obviously 0. So that's why it is in this sort of bluish color. And then as the distance increases, the data points color, it becomes more greener and greener. And at the highest distance within this data, it becomes this yellowish, right? So this is great because the farther these points from our question, the farther the distance, as we can see from the color. Okay. Now, if we set the scale by to contains answer, so here we have 20 data points with bigger size, right? So this is our question, and these are all the 20 documents retrieved by our retriever. So as you can see, you might think, but this data point is actually closer to our question. So our retriever might not be doing a great job because it should have picked up these two documents, these documents when it done the retriever job, right? So as I mentioned, the retriever one, it is computing the cosine similarity. Here we are looking at the Euclidean distance. But the more important point is the similarity is computed in a high dimensional space with 1500 dimensions. Whereas these distances or this visualization is done after reducing the dimensions to only 2. So there is some loss of information. Okay. But nevertheless, here we can see the documents retrieved by the retriever are within close proximity to our question, which is good as compared to, let me reset, as compared to the rest of the documents. So most of these documents are related to Elon Musk, and these ones are related to Steve Jobs. Okay. And also our answer contains also not distribution, sorry, page. Also, this is the response generated by our LLM which is also very close to our question as it should be. Okay, so quite nice. And going back, so here you can highlight or select the records. For example, okay, select it. That's our question. That's our answer. And if you want to visualize some records, you can do that. Sorry, one second. So here you can select some records. You can visually inspect. You can read the documents, etc. So this Spotlight tool, it has lots of functionality which you can explore. But this gives us a sense of how well our retriever is doing its job. How similar the extracted documents to our question, and also the generated response is to our question. Okay, so using tools like this, we can build some intuition how the retriever as well as the generator are working, and in this reduced dimensional space, how close they are to our question. I hope you find this interesting. Thank you very much.